Hello everyone, we welcome you for another edition of our monthly webinar. And today's topic will be on two-wire FXO FXS over the TDM network. And this will be presented by two of my colleagues, Vijay Kulkarni and Mike Yang. Thank you. Vijay.
Okay, thank you, Sanjeev. Okay, welcome everybody to our monthly webinar series where we try to give you a flavor for some of the technologies that are in the telecom space. Some of them are old and some of them are new. And today we're going to discuss a technology that's been with us for quite some time, but still is quite prevalent worldwide actually. And it's two-wire FXO FXS interfaces over TDM and VoIP network actually. So Mike is joining me. Mike Yang, my colleague, will explain some of our product line. We'll explain the technology and then we'll show you some of our product capabilities. Welcome. Okay, so very quickly, GL Communications, we've been in the test and measurement space for some time, since 1986. We've been doing telecommunications engineering consulting, as well as making test and measurement equipment, and our breadth for test and measurement encompasses wireless, VoIP, SONET, TDM, 3G, 4G, and now of course 5G. Our test equipment we like to at least think that it's very visual. It allows you to do capture, storage, and portable, and of course it's cost effective. So with that, let's continue. Okay, so FXO FXS, you might wonder what that is. Why is it called FXO FXS? What we're talking about here are analog facilities that they usually go to either the business office or a home. And these are usually, at least the last leg of it is a copper wire, and it's analog technology. So somewhere, of course, the telecom system has to become analog, and even with wireless technology, the endpoints are always analog. Now, the conventional analog technology has been called FXO FXS. This is the terminology used for what is called plain old telephone service. And it's just a holdover from the days when the people were given wide area coverage, local, so they call that foreign exchange, and that those terms have stayed with us. But really, what we're talking about is analog facilities, two-wire, a loop start usually most of the time. And the FXS side is the side that is providing battery, ringing voltage, dial tone, and so on. And then the FXO side is what we call the telephone side, which is actually accepting ringing voltage, receives dial tone, uses battery to power the phone. So this is a conventional two-wire technology, still very prevalent. Many phone systems are still that, although there is, of course, this migration to newer technology. So FXO actually stands for Foreign Exchange Office. That's just a term, but when we say FXO, again, we're talking about the actual machine, the phone at the end. FXS stands for the other side, which is usually the central office that is providing the line to the phone, and that usually has a number associated with it. It provides ringing voltage to operate to ring the phone, battery voltage to power the phone, and signaling to connect it to the end subscriber. So this is the basic technology. Now, why is it still prevalent, and why are we talking about that when most of the world is talking about 5G? Well, essentially, most of the world is served by cable companies, lots of channels, and cable companies have been basically deregulated, and they provide all services to the end customer. and they call them triple play. And this encompasses TV, internet, and phone. So, and these days they're adding more services to that. So it's sort of a package deal. And the home and or the office is usually a copper-based technology. So the technology used in the home is usually two-wire. So this is why FXO FXS becomes important. Major cable operators, carriers, all of them in the U.S. are using this technology. Some equipment manufacturers that supply the equipment are Motorola, Ribbon Communications, and so on, that provide this telephone service. So it's a complement to the wireless technology that we have that's quite prevalent now. So it makes use of the existing copper wire plant. And copper, of course, is still the dominant wiring in the world, actually, although fiber optics is gaining ground, but it's very expensive. So copper wire is used at the endpoints to for phone service. It is generally two-wire. Now, these cable operators, to compete with wireless companies and the wireless services that you have on your wireless phone, try to provide wireless-like features, calling features. We call them custom calling features, or they're PBX-like features. The nomenclature is Class 5 switch services. So what that means is you get all of these features that you normally would find on a wireless phone: call forwarding, call waiting, call transfer, conferencing. These days, since most of the backbone is IP. They can also transmit. They can also provide you wideband audio, not just the conventional 4 kilohertz. They can expand that to 8 kilohertz. So, because of the deregulation, because the wide open field, a lot of companies are in this ball game, and they're providing plain old telephone service to end customers. Okay. All right. So I'm going to have Mike help me a little bit, but one of the purposes of this webinar is to make you aware of the fact that the worldwide standards for FXO FXS, or two-wire loop, vary quite a bit, and they're usually regulated by what are called PTTs. So they have quite a bit of variation. Mike, do you want to kind of quickly go through some of these parameters, and we'll keep alternating?
Right, sure. So here we're showing you different call progress tones for different countries. So just as an example of what these tones may look like. So obviously each country generally have their own frequency that they use for different call progress tones. So let's just take a look at China, for example. They use the frequency 450 hertz to define pretty much all of their call progress tones. And the way you differentiate them is by looking at the on time and off time. So for example, like a busy tone, right? It goes on for 0.35 seconds and then off for 0.35 seconds and repeats continuously. Whereas the dial tone is just a continuous tone. The ringing tone is defined as having an on time of 1 second and an off time of 4 seconds. And these vary for different countries. So now if you look at the US, so some countries have the same frequencies that they use for all of their call progress tones. The US is sort of an exception to that, with the dial tone being defined as 350 hertz plus 440 hertz. So that's going to be a dual tone. So in the US, right, it's sort of each tone has its unique frequency as well as having its unique on time, off time. Dial tone is obviously still continuous tone. Busy tone now is defined as 0.5 seconds on, 0.5 seconds off, ringing with 2 seconds on, 4 seconds off. So the chart here is just to show you sort of what's the different definitions that different countries have. Our product, obviously, we can program them to work with all of these different regions. You can define the different call progress tones, on duration, off duration, and so on. And we'll show you that in the further slides.
Okay. Thank you, Mike. Of course, these different countries also have slightly different, not only the cadence and the call progress tones that Mike talked about, but they also have the actual line voltage and the copper wire, the powering of the phone, the length to which you can do that, because usually the central office is centrally located and the customer base is geographically distributed. So there's this whole copper wire technology that allows you to um, power all of the phones in that geographic area. So there we're talking about, there's an impedance. This column, this table kind of shows you a lot of the variations in a termination impedance, what the battery, for example, you have to power the phone, so you need a battery voltage. You need to be able to ring the phone with AC current, and so that is usually a very high voltage, and those ring parameters are sometimes different, or the cadence is sometimes different. So all of these parameters are slightly different for the different countries, and we're just showing you a sample here. All of these are we can emulate all of these in some of our product lines. Mike, did you want to add anything to this?
No, I think you covered it.
Okay, all right, good. All right, so one of the most important applications is the ability to, for these major carriers, is the ability to emulate hundreds, if not close to thousands, of subscribers and load their equipment, which is usually sort of gateways that convert to IP, or may not be gateways, it may just be conventional technology. So load testing and performance under load conditions is a very important thing. And so we provide equipment that can actually scale up to 192 ports, individual ports, and this is just a depiction of that. And you can actually increment this thing. You can scale it by using multiple such units. So this is one way of providing for carriers and for large manufacturers the ability to emulate a lot of two-wire FXO and FXS ports with all of these call features, being able to do monitoring. Mike, did you want to add anything to this?
Not right now. I think we have more on this later.
Okay.
I'll talk more about the channel bank solution later on.
Okay. All right. Super. And this thing can also, Mike will talk about VQT analysis and voice quality. Of course, voice quality is very important, and you want to try to be able to emulate or basically exceed the quality that mobile phones provide. Okay. So in addition to the bulk calling capability that some of our equipment provides, we also provide individual portable test equipment that allows you to emulate both FXO and FXS along with T1 E1 lines. They're sort of a combined product. And here, this is a very portable test instrument that does a single FXO FXS capability. And the FXS, of course, provides all of that, all of the feature set that we talked about, and the FXO provides the same, all of those call progress tones and those types of features. Okay, we have another product that allows you even wider variation of capability. This is called, but this is restricted to FXO only. Excuse me, but it has wideband audio. So these days, audio that is greater than 4 kilohertz wide is becoming more commonplace, especially because wireless phones have, you know, the AMR wideband codec. So to compete with that, wired carriers also provide wideband audio, and our portable product here supports wideband audio. It provides voice quality, supports 2 but this unit actually supports lots of other types of features, almost any endpoint capability. For example, you can connect to a wireless phone, this device allows you to automatically control the wireless phone, mobile phones that is, and it has 4-wire capability, Bluetooth, and other features that allow you to totally emulate the endpoint, whether the endpoint connects to a carrier or a wireless network or a wired network, whether it's 2-wire, 4-wire, wireless, or like, for example, push to talk, so on. All types of endpoint devices. It's also available in a totally, usually the prior products that I showed you require a PC platform to connect to and operate the software. However, there's versions of the product that allow you to control, have it completely independent, where the computer is built in, and all you have to do is use the unit as is. Okay, Mike, you want to talk about these?
Right, sure. So the two products that we just showed, the tProbe and the Dual UTA, so those are more portable solutions. They're very lightweight, very small. You can sort of carry it with you to different places. You can just connect it to a laptop, and it'll just work on the spot. The channel bank solution is a sort of a rack-mounted solution, so it's high density. There's lots of equipment required. There's hardware involved. And what we have here, so this is another way that we can include the tProbe and the Dual UTA in a sort of a rack-mounted solution. So these are what we call MTOPs. Basically, you can plug in different modules in each one of these platforms. So the picture here is showing you a tProbe along with the Dual UTA on the top picture. So 3 units connected into one, and put that in a 1U chassis, and you can rack mount it. And the second one is just showing you 3 different Dual UTAs rack mounted into 1U chassis.
Okay, thank you. So the tProbe FXO FXS emulation is a convenient GUI operation, and so there's a very user-friendly way to basically use the tProbe in 2-wire FXO FXS modes, and you can instantly start emulating an endpoint in any country, and start doing the call progress and operation, and make phone calls and do your testing. So GUI operation is one feature of our products, but we also have scripting and automation capabilities, which we'll talk about here momentarily. So MAPS FXO FXS is one of our products. I'm going to let Mike talk about that. He knows a little bit more about that. MAPS is our general platform. It stands for Message Automation Protocol Simulation. It is our general architecture for emulating all protocols, whether it's from 2-wire FXO FXS all the way to 5G. So it encompasses a wide technology breadth. Mike, go ahead.
Right. So again, MAPS is sort of the protocol simulation platform that we have here at GL. And again, it's used to drive many different protocols from 2-wire that you see here to 5G, as Vijay mentioned. So basically, it's a script-based simulator. It uses scripting to drive different call flows. So the 3 major sort of components of the MAPS architecture is scripts, profiles, and messages. Messages don't really apply in this case because it's sort of there's no real message protocol message being involved here. So we're looking at the scripting and the profile. Profile lets you define different characteristics of the FXO line, FXO or FXS line. You can configure stuff like I think the slide after this sort of shows you that, but you can define things like what number you want to dial, what different line characteristics that you want to define for your FXO or FXS line, things like the call progress tone information, the line characteristics, impedance settings, stuff like that. And the script has basically the entire call flow sort of defined in it. With the maps FXO FXS, we provide I think scripts for the FXO and the FXS side. On the FXO side, we have a place call script as well as an answer call script, and the same goes for the FXS side. Basically, in the place call script, it's got a sort of the basic 2-wire call flow defined in it. And what it'll do is it'll go off hook, wait for the dial tone to come in, dial digits that are again defined in the profile that we use. It'll wait for ringback, verify that ringback is there, and then once the call is connected, Maps has the ability to automatically send and receive different voice traffic. So things like sending voice file, receiving voice file, sending and receiving different tones, different digits, fax. And with the voice file, sending and receiving of the voice file, we can use that to perform voice quality testing. And what that involves is basically taking control of both the origination side and the terminating side. When we're sending a voice file, which we call a reference voice file, from one side, recording it on the other side, and then we'll compare the recorded file with the original reference file, do analysis on it, and give it a sort of a score that determines how good the quality is, whether there's noise on the line, whether there's any any degradation in the voice level and stuff like that.
So Mike, okay, so here there's a particular country called Brazil. Okay, I guess we have all of the cadence parameters associated with Brazil. The actual, I guess it's a single tone type of country, right?
Right. So in this picture, we're basically showing you the Brazil profile that you can define in Maps FXO FXS. So you'll see here there's different signaling parameters. What the definition is basically for a dial tone, for example. And we're using this MTD file to help us sort of recognize different call progress tones. So in that MTD file, you can define things like frequency. So we're labeling the Brazil 425 frequency as a label Brazil, and then we'll just use this label to sort of drive our scripting. Anytime a tone is detected with this frequency, our script will recognize it as the Brazil sort of call progress tone frequency, and then based on the cadence that's defined in a profile, we'll use this information to recognize the different types of call progress tones.
Mm-hmm.
So this is just one example of Brazil. I mean, with the software, we include a lot of different countries, and then each country has its own sort of unique definition for different call progress tones.
And I guess we have somewhere else where we can actually run a multiplicity of these scripts simultaneously to do the 192 channels of audio, right? And that's in our channel bank type of application.
That's correct.
So is that somewhere here?
That's sort of later on. So in this FXO FXS, so it is sort of limited to one FXO port at a time if you're using the tProbe. You can, of course, connect multiple tProbes to the same system, but it's sort of limited in the number of lines that you can have. So and most times you'll probably just be running one script at a time if you're using this platform to test your analog line. If you're going to the channel bank solution, that has up to 192 different lines for what we call a 1U maps chassis. And with that solution, you can control all 192 lines sort of independently. And we have an API that people use. It's very widely used by different carriers actually in the US. They use our solution to test basically the triple play application, right? You can assume control of any number of lines, make calls between any lines, have multiple users operating on the same platform. So it's a very sort of flexible solution in terms of testing analog features.
Right. So in this particular application, we can actually, so one of the things that we didn't mention at the very beginning was that a 2-wire FXO FXS has wide endpoint applications. That's just not phone, but you can actually have fax, right? And fax capability as well. So our products also permit fax emulation as well. You can send many, I think up to like hundreds of pages of fax per call. So both audio as well as image transmission over 2 wires. So that's one of the features, and of course you can do it in bulk as well. This is the actual bulk call generator, which is up to 192. The basic, I mean, this can scale up to 192, and then of course you can have multiplicity of these. And here we're talking, there's another picture. I'm sorry to jump around here, but I just wanted to show you that the bulk calling capability is also available, and along with the individual calls associated with the portable equipment. And we'll go back to our where we kind of jumped off here. Okay, so this is where we were talking about the single channel Brazil capability. Okay, all right. So it's all configurable. And we talked earlier about the line impedance, and we can also do, by the way, it's not just 2-wire loop start, 2-wire loop applications, but there are other applications associated with 2 wires, and those are called ground start and reverse battery and so on. And these are applicable in other applications, like, for example, 911 and other emergency line services where analog lines are also used. We'll probably get to that in a minute here. Okay, so sorry to jump around. Okay, now, so we'll continue with configurable FXS line parameters, same thing as FXO. We talked about FXO configuration here. This is for the GUI application. Same thing is available in the maps, our maps application that Mike just talked about. This is FXO line parameters, a whole slew of those. FXS, same thing. Okay, and here, okay, so here is actually a depiction of all the different countries that we were talking about and the different types of applications. You can see here that we can actually control the gain and the current and the low voltage trigger. So somewhere down below one of these slides, you can actually see the actual waveform associated with the line voltages as they are occurring. So this is something that's important when you're trying to do diagnosis. I don't know whether we have a slide of that or not. Let me just see here. Do we have that here, Mike? Where we have the line voltage and the ringing current and all of that? I don't think we have it here.
Slide 16 shows you some of the stuff that we can monitor.
Yeah, there's a graphic also. There's a graphic capability that allows you to see the actual, as the call is progressing, it'll show you the line voltages and the supervision, the on-hook and off-hook voltages. I don't think we have a slide of that, but that is also available. We missed that. Okay, so this is I mean, it's essentially a plot of this, correct?
Yeah, correct. So basically, we can plot the voltage and current over time, and you sort of see it in a nice graphical format.
Yeah. So that's very useful when you're trying to debug and you're having problems with your FXO or FXS line port on these gateways, for example, or ATAs. These days, there's a lot of VoIP carriers will use ATAs or gateways that have these massive number of ports, and sometimes those analog ports will have problems, and the actual voltages are useful there. Okay, I think we have. Let's see, where else? Mike, can you tell me what you'd like to discuss next? How about this? Well, we talked a little bit about this MAPS high density calling, right? The channel bank FXO simulation caller. Okay, so here are some of the features that allow you to do this channel bank FXO simulation, what we call class switch feature testing. And so actual carriers are using this capability, and this is available in API format. So if you had automation or regression testing or test scenarios where you implemented new feature sets and you wanted to do regression testing, this is where this comes in very handy. So all of these test scenarios can be emulated in your own test environment using the APIs that are available with this product. And those APIs are available for across the board, from the individual single port product to the multi-channel 192 port bulk calling capability. Let's see, I just wanted to, okay, so here are some of the basic functions that the API has. API is Application Programming Interface. So associated with all of these products, we do supply the Python. Mike, help me here. What kinds of?
So the API is available in Java, Python, Tcl, and .NET, and basically it gives you a set of functions that you can use so that you can define your own call flows, your own test case. And using these functions, you have very fine control of exactly how a two-wire call is going to flow, what sequence of the event should happen, and stuff like that. Using these functions, right, you can pretty much cover any of the class 5 feature testing, so stuff like call waiting, call ID detection, call forwarding, different things like that. FXK decoding is one of the features that we have here. So pretty much you just plug in a function, define your own call flow, and you can cover any scenario that you can think of when it comes to a class 5 feature testing. And this is used by lots of different, well, pretty much all of the major cable carriers in the US. They have our MapsCast with channel bank platform, where they test their MTAs, with the different features like that.
Okay. All right. I did find this is one of the graphs, I guess, that I was talking about, although there's another one here. I think maybe this is probably the audio picture, right? There was an actual line voltage picture that I was looking for that I guess we don't have that slide, but this is a typical detailed view of a two-wire call on the FXO side as well as the FXS side. And here you can see the actual call flow in detail, and you can play this audio as well. So all of these features are available within the software structure, and you can be recording while you're playing these calls as well, so that you can do the diagnosis a little bit later. So all of the call progress, not just the audio portion of the call, but the everything is captured end to end for the particular call. And here I'm talking about the starting with the ringing, the on hook, off hook voltages, the dial tone, dial digits, and of course in between the ringing, there's also a caller ID, right? So Mike, we support caller ID in all of its flavors, correct?
Caller ID, and call waiting, pretty much every form that you can think of. Yeah. And with the caller ID, you can also record this. The caller ID will be appearing in the FSK format. FSK is a frequency shift key, and you can record everything in the call and then do analysis later on, including analysis on the FSK. So it's a very good diagnostic tool with our software.
So caller ID is the methodology that they use in landline technology to send you the the calling party information that would appear on your phone. Normally on wireless phones, it's always present, but on landline phones, this is something that has this unique way of transmission in between the ringing voltages, and that is using this FSK modem technology. So that's all part of our software suite. So we do actually do the modem as well. I think I also mentioned that we do fax as well earlier. Here is just to give you a kind of a graphical flavor of a tone comparison between two different countries, USA and Japan. And again, as Mike had mentioned, there's a difference in the line supervision, which is voltages and ringing voltage and ringing cadence, as well as the call progress itself. There's a cadence variation, like a single tone versus dual tones. Dual tones in the US, is it dual tones in Japan also, or is it single tones? It looks like it's dual tones also in Japan. So, but maybe the cadence is slightly different. And the ringback is ringback tone. So all of those things are slightly different, and here we're capturing the two different countries and showing them side by side. Okay, so the other thing that we support in our applications is in the analog technology, there are different ways of sending dialing digits. One is DTMF, MF digits, and MFCR2 digits. These are at least 3 different examples of MF and MFCR2 are analog compelled forms of signaling that are prevalent in Europe, and MFCR2, that is, in elsewhere. In the United States, they use MF frequency for trunk signaling. Of course, on the subscriber side, what we use is DTMF tones. So our products provide both subscriber side signaling as well as trunk signaling capability. So that's I just wanted to mention that. Let's see. I wanted to just I hope I'm not skipping around too much here, but okay. So this is a very important application I wanted to mention. That's E911. Okay, and 911. And I'll let maybe Mike start, and I'll interject. But first, let me at least introduce it. 911 is, of course, okay, associated with phone technology from the very beginning. Phones are considered to be devices for emergency purposes. So that means that during an emergency, we assume that power may not be present. So therefore, you have to provide power to the phone. Now, that is generally the case even for almost all landline phones. And I think these days, even PBXs and triple play applications provide battery, at least temporary battery capability during emergency when power is disturbed. And the second most important thing that was introduced about 30, 40 years ago is 911 capability. This is emergency services that are part and parcel of telephone service. So almost all telephone services worldwide have to provide what is called in the US 911, but it is generally called emergency services elsewhere in the world. So every phone, whether it's mobile, VoIP phone, or landline phone, must provide 911 emergency services. And there are, the way it's done on 2-wire lines is something called CAMA, and I won't necessarily explain what CAMA is, just a acronym that is leftover from the way that accounting used to be done, but that's the word is being used in this 911. That is the prevalent way today, for example, that 911 services are relayed. So when you dial 911, you are immediately connected to what is called a PSAP, where a public safety answering point, where that agent receives your number immediately, and you do not have to convey that number. It's done automatically by the telephone network. Now, that requirement is a necessity for mobile phones, VoIP phones, as well as landline phones. So the emulation of that capability on conventional analog is something that we do, and we have provided to our customers. Mike, do you want to add anything to that?
Right. So sure. So this CAMA is basically it's a sort of a specification that that sort of defines the type of trunk that's being used here. So the way that works is that one side, whoever is placing the call, it will go off hook, and the termination side, typically the selective router or the PSAP, which is the 911 operator side, they'll detect the off hook, send a wink, which is basically a off hook on hook, send a wink signal to the origination side, and then the origination side will send its calling number information, which is called ANI, to the far side. So ANI typically is defined using MF digits. So the calling side will send those information to the PSAP or to the selector router. So this is sort of how you automate the PSAP will know who's calling, things like that. So what we have is on the tProbe as well as on the channel bank solution, we have CAMA simulation and monitoring capabilities. So we can generate calls or receive CAMA calls from and to the PSAP, monitor the CAMA line. So on the tProbe, using the FXO port, you can actually monitor for stuff like the line voltage and current and stuff like that. Using the channel bank solution, you're gonna get you're not gonna get the line voltage, but you will see different signaling happening. So stuff like going off hook, seeing the wink, and detecting the MF digits, things like that. So I think the picture here is showing us using the tProbe, generating a call to either the switch, the 911 switch, or the operator, and monitoring a call, sort of non-intrusively monitoring the call between a caller and a answering point.
Okay, thank you, Mike. All right, so that is that's a very important application, especially today when the 911 services are undergoing a lot of transition. Most of the U.S. still has this conventional analog 911 solutions from landline phones. Of course, 911 can also be originated from a wireless phone, but the way it is routed from the wireless technology to a public safety answering point still remains through this architecture here called the 911 selective router. So majority of the calls are routed to a public safety answering point in this analog methodology, or the complement of analog, which would be on a T1 line, T1 or E1 line. And there the signaling is essentially emulating the analog signaling. So this is still the majority of the calls. 911 calls are terminated in this manner. Although maybe 911 could possibly originate either on a mobile phone, a VoIP phone, or a landline phone. The actual termination of it is generally with this public safety answering point 911 selective router. Okay, and I wanted to one thing I didn't want to skip is we do have this. I think I mentioned earlier that the wideband technology, wideband audio, is also a feature of our VQuad analog phone simulator, where our Dual UTA HD unit, which has both narrowband and wideband FXO capability, and it can be provided in a high capacity solution. And this is being widely used by a bunch of our customers in their testing environments for providing triple play services. So this is something that is, the wideband technology. This is, it's very important when you're trying to measure voice quality, either using the standards for PESC or Polka. These are the two standards that are dominant in the voice quality business. Polka is the current standard that everyone is using. PESC is still very popular as well. So voice quality in all of these applications that we've just mentioned, voice quality is a important aspect of end-to-end service, and the ability to measure voice quality easily as you place these bulk calls or individual calls or wireless calls, whatever. The end-to-end quality is going to be a determining factor in whether or not your service is popular or deficient, I guess. So those performance metrics are very important, and we do provide that. Okay, let me think here. I just wanted to make sure that we cover most of the application. Mike, is there something that we've skipped that you can think of?
So just wanted to add onto that the channel bank solution. If you can go to slide 34.
Okay.
I think we sort of skipped on that part. So with the channel bank solution, you can of course define different regions for a different call progress on detection. Out of the box, we support about 20 different countries or regions, but this profile is fully customizable, so you can add as many regions, countries as you need to test the call progress tones for all those regions. And for each tone, you can define, of course, the definition, tone frequency, cadence, things like that. So fully flexible for testing different countries, different regions.
Okay. Sanjeev, do we want to take questions or comments that you may be collecting from our
Yes,
audience?
do you want to show those videos or not required?
Sure. Okay, let me do that then. All right, we have, which one should I show first, Mike?
Let's show the one with the ATA. Right, so this is basically showing you using the tProbe connecting the FXO port to a ATA. So the ATA is providing the dial tone, ring and stuff like that. And at the other end of the ATA, there's a real analog phone connected to it. So what we're going to show is using the MAPS FXO FXS software, we're going to place a FXO call into the ATA, and the call will be answered on the real analog phone. And then we'll just show you some of the call progress tones that's happening and what sort of signaling you can expect to see in the MAPS product. So here we're loading the USA testbed. In this testbed, you can define sort of the characteristics for the FXO and FXS ports. If you want to introduce any input gain, output gain, things like that, you can do that. You can set the termination impedance. So those things are generally defined already for you. So normally you wouldn't have to change anything, but the option is there for you if you need to change it. This is showing you the FXO FXS profile for the two ports there. And here's where you can define some of the call progress tone definition for a specific region. So this one, we've loaded up the USA profile. So you'll see here the ringback tone, the dial tone, those are according to the US definition. So in here, again, there are lots of different countries pre-configured in here for different call stones. There's also a traffic profile. Here you can define whether you want to automatically send a file, send a voice, send digits, tones once the call is established, and what the definition would be for those type of traffic. If you want to send a file, what the file location is. If you want to send a tone, what the tone frequencies, duration is, stuff like that. And here we're showing you the ATA configuration. So this is we're gonna set the ATA to a USA region. So it'll provide the different call progress tones for the US region. And then we're gonna place the call from the maps side, and we'll show you the sort of the call flow for this particular call. And that'll show up in the message sequence tab that you see in the bottom left corner. So we're going off hook, a dial tone comes in, and we're dialing digits, and then we're getting back ringback tone. For each of these tones, you can see the different duration that we're detecting. And once the call is connected, we're gonna start sending a file automatically. So for each of the tone that we detect, you get information like the frequency, the duration, power level, things like that. And we'll show you that gets displayed in the message sequence there in the GUI. So we've transmitted a file, and then after a certain predefined duration, we're sending the line on hook, which is basically disconnecting the call. And then we can detect that the far side has also gone on hook, and get a low line voltage displayed there, indicating that the other side has also gone on hook. So I think that's sort of concludes that video,
Okay.
basically showing you how this maps FXO FXS operates.
Okay. Okay. Here's the other video, Mike.
Right, so we're showing you the tProbe operating in a loopback mode. So we're connecting the FXO to the FXS ports. And in this case, we're going to be simulating both sides. The FXS port is going to be answering the call, and the FXO port is placing the call. So just in sort of a loopback self-test mode. We're going to configure the FXS. So in the first test that you'll see here, we're going to configure the FXS and FXO side to use the US region. And then in the second call, you'll see that it's going to show the Japan region. And you'll notice the difference in call progress tones, the definition of those tones. So in this profile, there's a definition for dial digits. So that's basically defining, where you want to place the call to. So that's defining the profile. So one side is simulating FXS, answering the call. The other side is doing a FXO place call. So we're basically just terminating the call on the FXS directly. There's no actual routing involved. This is just to simulate a sort of a basic two-wire call flow. So in this case, we get information on both sides. So on the FXS side, you get what digits were dialed from the FXO side, and the characteristics for each of those digits. And then from the FXS side, we're providing ringback and connecting the call.
Well, I mean, I would just interject one thing, and that is the ability to define the different tones and their cadences, and to be able to detect all of them simultaneously on hundreds of channels at the same time is a feature that's I think it's a very prominent feature of our product line, and it requires a lot of digital signal processing, um, as well as performance capability. And I think one of our product excels at that. And normally you would need to have expensive DSP cards to do that. However, we're able to do that relatively efficiently in our platform. Okay, so this is going through all of the different, okay.
Right, so in this case, we've loaded up the Japan testbed, and we're showing you the different FXO and FXS definitions for Japan. So the basic call flow is exactly the same as before. The only difference is which profile you're loading up.
That's the end of the video, correct, Mike?
Yes, it is.
Back to our screen here. Okay. Did you want to say something about our attendance at the? Okay, so one of the things that is happening at the moment in the technology space is that the air traffic industry is migrating to an all VoIP technology. So, of course, if you know, the air traffic controllers and pilots, as of now, use an TDM technology primarily and analog transmission to the to the jets and to the pilots, and all of the communications is done via TDM technology. So all of that is actually migrating to VoIP, and there in the VoIP space, not only the protocols, of course, a very important protocol, one of the basic protocols in air traffic management is the communications between the air traffic controller and the pilot. That communication is very critical to the safety of the entire system, to the landing of airplanes, to the takeoff, to the control of the of all of the flights, and that is not just for landing and takeoff, but also between the air traffic control centers that's in-flight planes that are in flight that also have to be controlled. So there, a technology that some of our products do utilize is this push-to-talk technology, and that is there's a very precise protocol to for discussion between a pilot and a air traffic controller, and that is this push-to-talk. So that's for legible, intelligible communication with the pilot and the air traffic controller so that they can safely control the air traffic. And since this is all going to VoIP, there's a transition from analog TDM technology to IP technology, and the protocols for voice communications have been standardized in some by the world community. And GL is a major contributor to that effort, and our equipment is being used, and we're going to be exhibiting at the World ATM Congress in Madrid, Spain, 12th to the 14th of March, and this little advertisement is what this is about. So we'll be presenting there, but more important, I think, is that the technology that this migration, even in air traffic control, is going to the newer technologies, from analog to IP, from TDM to IP technology. And so what's important there is that this the performance, there should not be any performance degradation in either voice quality or latency of communication. For example, whenever you press push to talk, if you're familiar with that type of communication, which is usually simplex communication between a pilot and a air traffic controller, one speaks, the other listens, and so on, and back and forth. That has to be very low latency. You cannot have any delays between the push to talk and being engaged and the actual speaking into the microphone. So there should not be any delay. There are some limits to the delay that is tolerable. Otherwise, the voice communication will degrade. So those protocols are part of that air traffic control suite, and that's what I've mentioned is one of the major aspects. In addition, there are all sorts of other protocols that are important in terms of preemption and other types of priority calls. So all of these things have been defined by the air traffic community, management community in Europe and in the US, and these standards have been promulgated, and we are supporting those standards, and we have products in that space that allow you to make measurements, performance measurements for latency and voice quality, as well as allow you to emulate those types of calls and be able to test the performance of equipment that is meant to migrate from analog to IP technology. So that's what this announcement is about. So if you're attending, our guys will be there, and they would love to talk to you.
Yeah, thank you, Vijay. Thank you, Mike. I think we can end this webinar. If anybody has any questions, they can send it to us at info@gl.com, and we'll get back to them.
Okay, thank you, Sanjeev. Appreciate it. Thanks, Mike.
Okay, thank you, Vijay. Thank you, Sanjeev.
Thank
Bye.
you.